Person-Environment Fit Aggregation, Part 2 of 2, Personality Psychology, Professor Michael Botwin, Department of Psychology, California State University, Fresno. Hi. In Part 2 of our discussion of aggregation, we're going to use classical test score theory to develop our ideas of how aggregation works and to show how it minimizes the effect of error on our scores and our ratings. Now, this unit is one that's particularly difficult for students to grasp. So hopefully in this video format, you can watch it a couple of times and make sure you get the idea down. But if I can give you any hint, this is a topic I consider extremely important for this class. So let's take a look at classical test score theory and aggregation. To understand how aggregation works, we're going to use classical test score theory from psychological testing to help you understand this concept. First, we need a few definitions. Observed score. This is the measurement of an event. It is essentially our data. It is what we record as data in our studies for an individual. Now, any score is also potentially contaminated by error. And error has to do with things basically mucking up our measurements, and we want to minimize error. There are two forms of error: random error, which we can't control, and when you aggregate data, theoretically over many observations, random error will cancel itself out. The second form of data is systematic error, and this may be due to biases in our measurement or miscalibration of instruments or raters. For example, if we have a scale that is not accurate, we all love those scales that make us 5 pounds lighter because it's miscalibrated. But that is a systematic error. The scale that measures someone lighter 5 pounds will measure everyone lighter 5 pounds. Hopefully, we can minimize systematic error the most we can and get rid of those effects. But there's one more component to our formula for a score. That's essentially the Holy Grail. What we're looking for, what anyone is looking for when they do measuring. And that's the true score. And the true score is not contaminated by any kind of error. It is the score we strive to obtain in measurements, although we realize it's like the Holy Grail and we can get close to it, but we can never actually get that true score. You can get close to assessing a true score, but you have to remember that all measurements have error. And a true score is the measurement of an event without any contamination at all. We're going to use classical test score theory to further our understanding of the concept of aggregation. Now, we've already defined our score terms. We have our observed score, which is simply two things. It is our true score and error. So let's look at this in a little bit more detail. This is the previous formula with a minor expansion. So we have observed score equals true score plus error systematic and error random. We can split that term in two theoretically. In reality, we can't, but this is a theoretical exercise. Let's use an example here. Let's say that we have 5 individuals rating a person for we love extroversion. Let's use that as a concept. So we have a 7-point scale for extroversion. We have 5 different people rating a target person, and each of them is holding up their scores. So we have 2 4s, a 5, a 3, and a 7. Each one of these individuals has their own formula for the observation that they're submitting, and it simply equals the observed score plus true score plus error that we previously talked about. Now we've introduced the nasty and thorny concept of the subscript here, and if you look, we have simply R1 for rater 1 to R5 for the 5th rater. That simply identifies who's making the observation here. So let's take these ratings and see how aggregation works. We have our 5 people, and we simply take the arithmetic average of all 3 of these terms. Theoretically, all 3 terms. In reality, we're just averaging the 5 observed scores. So when we do that, we get the mean of the 5 raters' score. Now this will flatten out the effects of the 3 and the 7 on the ratings because it's mitigated across 5 different observers. Now let's expand this just because we can. And we have the same concept. We're taking the average observer score across all 5 raters. This is our aggregated score. But theoretically, remember, over many observers, random error cancels itself out. It sums to 0. So by simply aggregating across raters, we help to minimize that random error term. So let's look here. We have random error, and that'll cancel out over multiple observations. In a good study, systematic error will be small if our study was designed well. And we have a too fast click there. So bottom line is our observations will more closely approximate our true score by minimizing the error. And any scientist doing any form of measurement attempts to minimize the effect of error on their scores. In psychology, aggregating is a good way to go. So let's look at the bottom line on aggregation. Why is aggregation useful? First of all, it minimizes the effects of each score averaged. So if you have an outlying rating, that may be flattened out by having multiple raters. It also marginalizes the effects of ratings that may have been affected by extraneous variables that may affect one of those ratings. And as we've already talked about, theoretically it eliminates random error in the aggregated score. So this technique is extremely useful, and it's been employed wonderfully well in personality psychology, because when we use the aggregated ratings of an individual's personality, either over time or number of raters, we get a better perspective of their personality traits. And as you saw in the previous part of this lecture, with Jonathan Cheek's example, you get far better correlations between your criteria variable and your predictor variable if you use aggregated data. This is a We Are Couches video production. Copyright 2020, Professor Michael D. Botwin. All rights reserved. Bye now.